Hey, so we're going to talk about titration. Titration is when you have an acid and a base and you're using that phenomenon of an acid and base making water. Pour some in here and just show you that pure distilled water should have a pH very close to 7. And I have this great stuff called universal indicator, which turns a different color for every pH. So as you can see, that's green is neutral. So it's sort of a greenish yellow. And then if I add, this is 0.1 molar HCl. All right, so if I put some indicator in there, that will show that it's pH of about 1, so it's going to be sort of a pinkish red. All right. And then here I'm going to put some base. This is about the same base. If I put that pH indicator in there, you will see that that turns sort of a purpley blue. All right. So what we have here is we have a base. So the base is purple, and the acid is red, and the neutral is greenish yellow. Right now it's a little yellow, I guess. So it really takes very little acid to turn strong acid. This is strong acid, strong base. This is HCl. That's sodium hydroxide. So as you can see, I can just add like a drop of acid to water, and it turns into a pH 1. So a strong acid, water won't fight to maintain its pH in the presence of strong acid, and it won't fight in the presence of strong base to maintain its pH. So if I add the same drop of base, hopefully that works. There you go. Turn to base. So water's not fighting, right? Water's pretty much just doing what water does, which is it'll be acidic if there's any acid in it, it'll be basic if there's any base in it. So what we're going to do now is we're going to do what's called a titration.
So an acid-base titration will reach the equivalence point when all the base and acid react and make water. And that's what we're shooting for when we do most titrations. We're trying to get to a point where there's no acid and no base, just water in there. And we'll use this equation where the molarity of the acid times the volume of the acid will equal the molarity of the base times the volume of the base. Because when there's nothing but water in there, all the acid reacted away, all the base, and vice versa, so that it was water. So another way to look at this is if you're playing Space Invaders, you're shooting, in this case, OHs at the H pluses. Every time one hits, one of the H pluses disappears and becomes water. But all of these things are H pluses. So we have to just keep adding and keep adding until everyone is gone. And that'll give us a nice curve like this, where there's low pH as there's more acid in there than base. And then when we get to a point where we've killed most of all these H pluses, we will be here. And then the next drop or two of OH will get us to our equivalence point.
All right, so I'm going to put 10 milliliters. Almost got 10 milliliters of this 0.1 molar HCl into here. And I'm going to add a whole bunch of indicators so you can see that nice red color. All right. I'm going to start adding it. And what you'll see is as that base initially goes in there, it's all still acidy. But there's going to reach a point, it's on this side, where that base starts lingering. And then as it reacts with the acid, it becomes water, and then what remaining acid is there remains. So we can put some more in there. And when that lingering happens for a long time, we know we're close to the acid and the base being equal. So you keep adding this. I'm really getting close, I think. And you don't want to go too far, because if you go too far, then you won't see that green and you'll have made it base and you'll have gone too far for it to be water. So I want to kind of stop when it's that green color and not when it's purple. as you can see, that base is lingering, and it takes more time for it to react away. There's less and less acid in there to make it go away as we get close. And ooh, that was just about it. So it shouldn't take but a drop at this point, because as we just saw, it really doesn't take much. So there you go. So that is the titrated amount. So whatever I ended up on.
So basically what we did here, I took 10 milliliters of 0.1 molar HCl in the cup, and I'm adding to it unknown NaOH. So I don't know what the concentration is of the NaOH, but I'm going to add a known amount of it, and that's what I did. My burette started at 11.8 and it ended at 18.0. So my burette started at 11.8, and then I kept adding liquid down to the point where it was at 18.0. So the difference between those two is the 6.2 milliliters, and that's base. So now using my equation, where the molarity of the acid times the volume of the acid will equal the molarity of the base times the volume of the base, I now know the molarity of my acid, right, is 0.1. That was the acid that I started with. So I have 0.1 molar, and I use 10 milliliters of that. And then the molarity of the base, I don't know, but I do know that I used 6.2 milliliters. Now again, because milliliters are on both sides, they'll cancel. So that's fine. Then 0.1 times 10 is 1, and that'll equal the MB times 6.2 milliliters. And so MB equals 1 over 6.2, which is, if I divided by 6.2, is 0.16. So the molarity of my base was 0.16 molar. And that's how you figure that out.